Hi everyone, I'm Ruochen, and I'm currently a first-year CS PhD student at Brown University, advised by Professor Carsten Eickhoff. Today, I'm presenting our new resource paper, Soccer, an information-sparse discourse state tracking collection in the sports commentary domain. The task of state tracking has been a long-standing interest in natural language understanding research. It helps to reduce ambiguity inherent in language within a temporal process like dialogue systems by maintaining a consistent representation of state. Therefore, the most widely known application of it is on task-oriented dialogues. In this system, it usually involves a user and an agent, and the agent's trying to satisfy users' request by completing tasks such as reserving a table, calling a taxi, and etc. So in this setting, it's important for the agent to accurately estimate user's goal as the conversation progresses, hence the task of dialogue state tracking, with state being user's requests. In this example, we can see that the agent needs to identify user's requirement on specifics of the restaurant, such as the area of it, and it should also speculate the attraction area later on by accessing information a few turns ago. Another area has seen the task of state tracking is procedural tasks, and this usually includes cooking instructions, instructional manuals, or just any temporal processes involving text descriptions. Taking this instructional manual as an example, when we're reading the first step, we as humans are able to fill in the gap and know that the window will become dirty, but machine doesn't. So with the notion of state being the entity properties, this tracking task helps machine to understand unstated situations and could potentially benefit other reasoning-based tasks, such as automatic execution of biology experiments or just help with our daily cooking processes. However, if we look at the established datasets from these two areas, we find that even though the state definition varies, but the discourse structure is very similar. Dialogues and menus are both short and information-dense pieces. To bring more stats, there are few turns per dialogue or menu, and each turn is less than 20 words. But we can always expect at least one update per turn, which is very frequent. In this context, language aims to convey as much information as possible and therefore is highly concise and functional. But what about other types of discourses that may go beyond several steps or short sentences, yet the state updates are less densely distributed across the corpus? And what would be the definition of state in those settings? So what we like to have is an information-sparse collection that differs from the currently available datasets with easily definable states that could open up the task of state tracking to a wider range of discourses. An alternative interesting scenario to look into is sports competition, for example, a soccer match. We all know that a soccer match is kept with a maximum time limit, which starts with some players on the field, and a commentator usually describes the game events live to the audience. As the game starts, players start to run around, and the commentator will try to fill in the gap with some chatter to keep the audience entertained. At a certain timestamp, we may see a key game event happening, such as someone guessing a goal, or even multiple events can happen at the same timestamp until the minutes run out. So now we see a similar setup compared to the previous state tracking tasks where we can have a well-defined state, in this case being the key game events. Each update is also accompanied with rich commentary resources and a nice temporal relationship between them. So in the context of soccer matches, the states would be the key game events including goal, assist, yellow card, red card, and player switch for both home team and guest team. So 10 states in total. And the state tracking task is therefore given commentary. We want to accurately track the occurrences of key game events. We also propose tasks with two levels of state granularities. First, on the team level, we want to associate in-game events with a team-level actor. In this example below, given this comment, we want to identify a goal action associated to the home team. Then, at a significantly increased resolution, we want to associate the task with a specific player name as the example shown below. Motivated by this task, we present our dataset Soccer, which contains over 2,000 of matches with more than 135,000 pieces of commentaries and 30,000 of in-game events. We collect our data from Go.com, and here you can see a snippet of a specific match within the dataset. Each match record contains rich meta information, including date ranging from 2016 to 2020, competition title that belongs to one of the 4 major competitions shown here, and team lineups that can potentially help with player reference resolution in the commentary. As the key components of the state tracking task, it contains temporally aligned timestamp commentary and states. In the state of each timestamp, we correspond to the key event occurrences with its player actor, which is the ground truth label for our player level task, and the ground truth for the team level task can also be easily induced. To quantify the difference between soccer and the existing datasets, we define the metric information density ID as the total number of state changes over the total number of turns or steps or timestamps. This differentiates from the information density concept mentioned in the uniform information density theory, which focuses on explaining the syntactic reduction phenomena on the utterance level, but here we are computing the score on the dataset level. In the comparison table, we can see that the soccer has longer prompts per turn, significantly more turns, and less frequent state updates, resulting in a much lower ID score. With a much different soccer dataset, we experiment with 2 different baseline models for both of our team level and player level tasks to measure the difficulty of state tracking in an info-sparse dataset. The first is the GRU classifier with input as contextualized bird embeddings for each piece of the commentary. The output of GRU then get passed into feed-forward layers for binary classification on the team level task. So the prediction is a 10-digit binary variable with 1 indicating the occurrences of an in-game action from a specific team. The second baseline model is inspired by competitive baselines used for both dialogues and procedural tasks. Here we have a specially formatted concatenation of commentary and in-game events with the corresponding actors from the input sequence. This makes the model suitable for both team level and player level tasks. The training and inference then follows the autoregressive fashion of GPT-2 that allows us to model the joint probability between the commentary and the state updates. For the metrics, we use accuracy and positive recall for the overall evaluation. The positive cases referred here for convenience are commentaries with event occurrences, and similarly the negative cases are commentaries with non-occurrences. On the right side, we can see the overall accuracy for both baselines are around the majority baselines, in this case which is the ratio of our negative cases within the test set. In comparison, the ability to detect event occurrences reflected by the positive recall score here are significantly lower, especially for the player level task. The GPT-2 variant only achieves 7% of positive recall, while a similar structure model is able to reach a high 50 on the dialogue dataset. To further demonstrate the challenges posed by the soccer dataset, we also experiment with subset of varying information density. Notice that the common sparsity here refers to the ratio of negative cases within each match and is of inverse relationship with the information density metric. So higher the sparsity, lower the density. From the table below, we can observe that as sparsity goes up and ID goes down, the overall accuracy increases due to chance agreements on the negative cases, and positive recall decreases as there are much less positive cases occurring. In summary, we present soccer as the first information-sparse collection designed for state tracking tasks in general discourses. By introducing the notion of information density, soccer joins the currently available resources and advanced discourse state tracking to a broader range of settings. Finally, with state tracking tasks applied in diverse scenarios, we hope to distill better state representation within big language models, working towards a more controlled text generation approach. With that, I would like to thank you for your attention, and please find our code and data via accessing the QR code below.